Have you ever wondered why elements behave the way they do, reacting differently under various conditions? Or why the periodic table looks the way it does, with its unique arrangement of rows and columns? The secret lies in electron configuration, the way electrons are distributed in an atom's orbitals. Welcome to Science Bites. Today we'll dive into how electrons are arranged in atoms, exploring the principles that govern their placement. We'll also see how this arrangement shapes the periodic table, influencing the properties and behaviors of elements. Electron configuration refers to how electrons are arranged around the nucleus of an atom. Electrons occupy specific energy levels, or shells, with lower energy levels being filled first. The number of electrons in each shell determines an element's chemical properties. For example, hydrogen has one electron in its first shell, while neon has a full first and second shell. To understand electron configuration, we use the Aufbau principle, which states that electrons fill the lowest energy orbitals first. Electrons fill in a specific order, first in the s orbitals, then the p orbitals, and so on. For example, oxygen's configuration is 1s2, 2s2, 2p4. The periodic table is arranged according to electron configurations. Elements in the same group have similar configurations, meaning they have the same number of electrons in their outermost shell. This is why elements in the same group, like the noble gases, have similar chemical behaviors. The electrons in the outermost shell, known as valence electrons, play the most significant role in chemical reactions. These electrons are the ones that interact with other atoms, forming bonds and breaking them, which leads to the various chemical reactions we observe. Elements with a full outer shell, like noble gases, are stable and non-reactive. This is because their valence shells are complete, making them less likely to participate in chemical reactions. They have little tendency to gain or lose electrons. On the other hand, elements with only one or two valence electrons, like sodium, are highly reactive because they easily lose or gain electrons to achieve stability. This reactivity is what makes them so important in various chemical processes, as they readily form new compounds. So, the arrangement of electrons within an atom not only determines an element's position on the periodic table, but also its chemical properties and reactivity. This arrangement explains why elements behave the way they do, reacting differently under various conditions. Electron configuration is the key to understanding chemistry at its core. It helps us predict how elements will interact in chemical reactions. Next time on our series, we'll dive deeper into the fascinating world of ions and isotopes, and see how even small changes in atomic structure can lead to significant differences in chemical behavior and properties. Stay tuned for more bite-sized science. We have much more to uncover and explore. Like and subscribe for more bite-sized science that makes the universe easier to understand, one concept at a time.